Hi everyone, this is Ravinder. Now in this video, I am going to explain about machine learning workflow. In previous video, we discussed about machine learning introduction and its categories, supervised, unsupervised and reinforcement algorithm, its applications. Now I want to explain about machine learning steps, stages, workflow in order to generate accuracy model. The machine learning workflow refers to the series of stages or steps involved in the process of building a successful machine learning system. That means in order to build an intelligence model, we have to follow a series of steps. So those steps are called data collection, data preparation, choosing a best learning algorithm, and we have to train the learning algorithm and generate a model and evaluate it and test the model in order to get a target value. So these are the stages in machine learning workflow. First stage is data collection stage. In this stage, the data is collected from different sources. For example, exit polls in general elections, assembly elections, Lok Sabha elections. The exit poll companies, they'll get data from different sources, websites, files, social media. Different people, they'll gather the data. Youngsters, employees, businessmen, ladies. Right? So that data is called as what? A training data set. After getting that training data set, that is collected from, depends upon type of desired project also. Yeah. So whatever data you are going to collect, that is depends on a project. If it is related to banking sector, so we have to collect data from the related sources. If you are developing a model which is to predict exit polls, then we have to collect data from different sources. For example, social media and people. And the data may be collected from various sources such as files and database also. And the quality and the quantity of gathered data directly affects the accuracy of the desired system. So here whatever data we are collecting is referred as raw data. So that raw data definitely affects on desired system. So based on the desired system, we have to collect data. That is important. We have to link it. You have to keep that desired project in your mind. Based on that, you have to collect the data. Now coming to the data preparation. So after collecting data from the different sources based on desired project, now we have to prepare the data. That means data preparation means what? We have to clean the data. So whatever data we have collected from different sources is not accurate data. So before creating a training data set and feeding to the learning algorithm, so we have to clean it. Then only we'll get accuracy data, accuracy model, a desired model, which gets a desired output. So that collected data is referred as raw data, which cannot be directly feeding to the learning algorithm. The raw data may contain missing values. Why we have to, one question is there, why we have to clean the raw data after collecting from different sources? You make the question. The thing is what? So the raw data may contain missing values, inconsistent values. No, the not related values will be there in that training data set. It's not training data set, it's raw data. not related data will be available in that raw data. So we have to remove it. And duplicate value will be there. The same data may be repeated n number of times in that raw data. Now, if you, after collecting the data which includes missing values, inconsistent values, duplicate values, if you feed to the total data to the learning algorithm, you won't get, it won't generate desired algorithm which doesn't get the desired output. That's the reason this stage data preparation is very, very important. We have to clean, we have to remove all these missing values and etc. Now, in order to clean the data, raw data, there are different methods are available. Now, we have to ignore the missing values. We have to remove instances having missing values from the data set, removing duplicate instances from the data set, normalize the data in the data set. These many steps are there, methods are there to clean the data. Now coming to the next stage is choosing learning algorithm is very, very important. That means after collecting raw data from different sources based on desired output, desired project, after cleaning everything, now we have a training data set ready with us. Now we have to choose the learning algorithm. Whether the training data set includes labels. If training data contains a label data, if it is label data, then we have to use supervised learning algorithm. For example, naive-based algorithm is there. If training data set contains labels, then we have to choose naive-based algorithm. That comes under supervised learning algorithm. If the training data set doesn't contain label, then go for unsupervised learning algorithm. K-means algorithm is there, for example. The K-means learning algorithm under unsupervised learning algorithm. The best performing learning algorithm is research. Yes, we have to research it. In order to choose the best learning algorithm, we have to do research. How we can perform research? Already, we collected data from different sources and we clean the data. So based on that data, we have to do research. I told you very clearly whether the data contains labels or data doesn't contain labels. Based on that, we have to choose the learning algorithm. That choosing that learning algorithm depends upon the type of problem that needs solution. Yes, we have to research the data. Okay, that learning algorithm depends on type of problem we have chosen and the type of data we have. So based on these two parameters, we can choose the learning algorithm. If the problem is to classify and the data is labeled, yes, I told very clearly. If the problem is classify, we need to classify and the data is labeled, then the classification algorithm are used. If the problem is to perform regression task, it has continuous values, it has continuous data, and label data is there. The data contains continuous data. Training data set contains continuous data and labeled. Then we have to perform regression algorithm. If training data set contains labels and it has discrete values, then go for classification algorithm. The problem is to create clusters and the data is unlabeled. Yes. Now whatever data we gathered and data is as cleaned, researched. After that, if training data set doesn't have any labels, then we have to perform. What's the problem here? What's the problem here? We have to cluster, no labels. Then go for unsupervised learning algorithm. Yes, these are many learning algorithms are available in machine learning. Yes. Now we can categorize broadly machine learning algorithm supervised and unsupervised. Under supervised algorithm, classification and regression algorithms are there. Under classification, k nearest neighbor algorithm is there. Logistic regression algorithm is there. Support vector machine learning algorithm is there. And a naive based algorithm is there. Decision tree algorithms are there. These algorithms comes under regression, classification. I'm repeating. All these algorithms comes under classification of supervised learning algorithm. That means the training data set contains label and the data is discrete data, separate data, distinct data, yes or no data, 0, 1 data, true or false data. That's the reason we have to select these algorithms. If it is regression, if data is labeled, but data is continuous data, fractional data, in that case you have to choose these many algorithms. Linear regression, support vector regression, decision trees, Gaussian progress regression, and ensemble methods. And coming to the unsupervised, that means training data set doesn't have labels. Now what's the problem here? The problem is to cluster. We have to groups the data. In that case, we have to go for unsupervised. What are the different learning algorithms are there here? Gaussian mixture, k-means clustering, boosting algorithm is there, hierarchical clustering is there, and spectral clustering is there. So these algorithms are used to as a learning algorithms in order to generate a model. And after that, the next stage is there, training the model. After choosing learning algorithm, then go for train the model. The model is trained to improve its ability. Yes. Right? The model must be trained in order to get ability to gain the accuracy data output. The data set is divided into training data set and testing data set. Yes, we require testing data set as well as training data set. Training data set will be used for giving input to the learning algorithm. But what about testing data? Testing data we can give it to the model, the whatever model we generated. So the testing data will be used as an input to the generated model. So this testing data should not be used as a training data set. So it depends upon size of the data set. Yes. The training data set is used for training purpose and testing data set used for testing the purpose. Testing a model to generate accuracy. Training data set is fed to the learning algorithm. Yes. After training the model, we have to evaluate it. Before evaluating, if you go for directly giving input and getting output, we may get a wrong output. So before going for exact testing, we have to evaluate it. The model is evaluated to test if the model is any good or not. The model is evaluated using the kept aside testing data set. Yes. While generating data, while collecting raw data, and after applying different methods to clean missing values, we have to kept aside testing data. That is important. Right? So already I have given best example, right? Elections, exit polls. So whatever data we collected, that is what that is training data. The original voted data is there. That is what input data, testing data. So metrics such as accuracy, precision, recall, etc. are used to test the performance. Yes. While evaluating the model, we we have to test the accuracy, precision and recall. If its model is not good, we have to recall it. And again, we have to give the training data set and generate a model till getting the accuracy model. The accuracy may be further improved by tuning the hyperparameters. Yes. So these parameters are called as what? Hyperparameters. By tuning the model. But for example, after training the model, after evaluating, if you're not getting a good accuracy data, by using these hyperparameters, we can tune it, improve the model and generate the accuracy model to get the accuracy data. And predictions. So in this stage, the built system, the whatever system we have built, is finally used to do something useful in real world. Here, the true value of machine learning is realized. So that is what the predictions. So this is the workflow of the machine learning algorithm we discussed so far. And next session we'll discuss about how to implement each and every algorithm with the TensorFlow. Thank you everybody. Goodbye. Take care.
Like, share and subscribe. Hit the bell icon for more updates.